So I'm Adam Brundage. I'm a director of the Global Sustainability Analytics team here at Nike. Been with Nike for about 6 years, but been with the industry doing carbon footprint analysis, sustainability assessment for about 10 years or so. So just kind of giving you some background. And, you know, unlike you guys, when I was in grad school, we didn't actually have courses on LCA. So for me, it's sort of a passion and a sort of science and methodology that I've learned just in application. So I'm not technically an LCA expert, although I know a lot about it. So if there's any questions that I can't answer, I will try to get back to you with more expert people who can give you the answer.
I would say you're an expert in the context of using LCA in our industry though, right? Which to your point,
Sure.
And then there's this whole other pool of deep technical experts in the science of LCA, which is what you're being modest because, you're not part of that group, but truly it's really been a field that's evolved, I would say, and quite rapidly over the last 5 to 10 years of being able to apply LCA for the purposes of sustainability in the apparel and footwear industry. So
absolutely. I mean, like with any kind of science or methodology, there's like theoretical applications and there's constantly evolving kind of science to make it better. And then there's how you apply it for a brand or company that makes, thousands of different products every year and wants to use this methodology, not just for reporting, but for understanding how to improve products, how to make things more sustainable, how to make things better. So that's kind of one of the themes of this talk. And, again, happy to take any questions. All right, so just jumping right in. So you all can see my screen? Good?
Looks good.
Cool. So yeah, so we'll walk through some of the climate footprint and strategy at Nike, context setting, get into an intro to LCA, which is a little bit about the theory, talk about how we apply it at Nike, looking at some tools and resources, then obviously leaving for questions, but again, ask questions along the way. All right, so footprint and strategy. So anyone who's looked at all at the apparel footwear sector, Nike in particular, it's no surprise that we are very passionate and engaged in the sustainability assessment world. We've delivered Nike impact reports or sustainability reports every year. We have recently committed to science-based targets, which means that we're taking responsibility for our carbon emissions in line with science, essentially the Paris Accord for private sector. And looking how to reduce our impact across our full value chain. So we have this goal by 2030 to reduce our total carbon emissions across all 3 scopes, scope 1, 2, and 3, which is essentially our full carbon, sort of our full value chain, all the way back to the raw materials, manufacturing, transportation, the whole value chain. We aim to reduce our footprint by 30% from what our footprint was in fiscal year 15. So it's essentially this graph here you can see is like, as we're growing and making more things every year, we plan to reduce our carbon emissions in line with that science. And so we have this sort of end goal. We have obviously milestones along the way. Every 5 years, we come up with targets that aim to reduce impact in different parts of our value chain, and we hold functions accountable for that. So there's a lot of impetus for us to assess our impact over our value chain and report on the progress we're making, not just for our consumers, but for our investors, and to be just good stewards of the planet. And so carbon is sort of our biggest impact area, or the one that we care about the most. Not that other impact areas are not important. So like water footprint, our chemistry impact, our energy footprint. But for us, climate change and carbon emissions is sort of our top priority. And so we've aligned on our kind of purpose, vision, and strategy. We want to make athletes asterisk, so that means anyone with a body is an athlete. We want to make them better, right? Giving them more performance products, but at the same time, make the world better for athletes. Obviously, climate change is an existential threat to sport. If you can't go outside and play sports, then, what are we doing here as a company making, shoes and shirts? And so that purpose is codified in our vision to create more sustainable product. We've kind of calculated that based on our growth projections and based on our climate goals for 2030, What that looks like is that we have to make product that has a 70% reduction in carbon footprint. And that's a big, tall order for us, but it's something that we're very passionate about, and we think we can achieve through innovation, through various initiatives in manufacturing, through efficiency, et cetera. And so our strategy is to basically inspire this culture of sustainability, empowering, everyone else at Nike, from developers to materials gut people to innovation, to understand sustainability assessments and to help create products that reduces our impact. So again, what that looks like for us is we want to reduce our overall average carbon footprint per pair per unit. So we make, garments for apparel, we make shoes. We want to reduce those impacts by roughly 70%. And we've calculated just over the years sort of our average carbon footprint for both footwear and apparel. And what it comes out to is roughly 10 kilograms of carbon for footwear and 7 kilograms of carbon for apparel. I'm showing here just footwear just to kind of give a simple example, but 10 kilograms of carbon is like the equivalent to burning a gallon of gas, right? So driving 20 miles or so, that's basically like the emissions associated with making a pair of shoes. And we make every year roughly 600 million pairs of shoes. So that's a lot of carbon emissions that we're putting into the atmosphere. And I'll get into a little bit more about where those carbon emissions come from and how we calculate, but just wanted to give you a high level overview of that. So quick poll, which of these 4 Nike models, footwear models, would you say has the highest carbon impact? And I don't know your level of life cycle assessment or carbon footprint understanding, so there's no wrong answer here. But knowing that the average is 10, and you're looking at these products, can anyone give a guess which one has the highest?
Ooh, good question. Maybe type your guesses in the chat. Yeah, Sarah. Air Force One, a couple votes for Air Force One, Air Max.
Okay.
Yeah.
No one's saying the LeBron. Okay.
NXT, no, we got one. We got one vote for LeBron, a couple for NXT. Yeah.
All right. Well, whoever said Air Force One, you are correct.
All right.
All these pairs are obviously higher than the average, and it's sort of intuitive. The more sort of stuff you have on a shoe, the more carbon intensive it is. So the Air Force One is a pretty heavy shoe. It has an airbag inside. An airbag is basically our cushioning kind of technology that you sometimes see on the side of an Air Max. It's this little bag here, but it's hidden inside the Air Force One. And it also has a lot of leather that's used on the upper. And leather actually is a pretty carbon intensive material. Basically because we're allocating some of the meat, the cow raising life cycle to the leather that we then use. So it actually has a very high carbon footprint. So anytime you have a product with leather on it, it's going to have a high carbon footprint. So good guesses all around. So besides these 4, we've also looked at other models. And as I said, it really spans a range of impact. One of our lowest impact shoes that we've made to date is a shoe called Space Hippie, which was really intentional to make sort of, think about sustainability, design for sustainability. We're using a lot of waste materials in the upper. For example, it's shredded up old T-shirts that we've then spun into yarn and made an upper out of it. It's these speckles here you see on the outsole, on the midsole here is actually like ground up rubber that we've then incorporated back into the foam. The foam itself is a byproduct of another foam making technology. So it's sort of waste. It's all waste incorporated materials, which comes with a lower carbon footprint. So we intentionally made this shoe to see if we can achieve a super low carbon footprint. And I think we accomplished that. But then there are other models too, like the Tangent, which is, simple, lightweight product that also comes with a low carbon footprint. And it goes all the way up to, Air Force One, which I just talked about, is one of our higher carbon footprint shoes. And I should say that, these products, what we're analyzing here is the impact across the manufacturing and materials that we use to make the shoe. I'll explain this later, but it's something called cradle to gate LCA assessment. So we're looking at the materials that go in, that they're sort of how you convert those materials into the various parts of the shoe, and then the manufacturing to bring that whole shoe together. And it's sort of as the shoe leaves the factory gate, so before transportation, before end of life, this is our impact. And we look at it like that because that's kind of what we can control in the sort of design phase. Yes, we're looking more into durability and end of use or end of life to kind of see how we can sort of start to design for circularity, and there we'll have to kind of account for those other parts of the value chain. But the majority of the impact is coming from the materials and the manufacturing, the method of make. And it roughly breaks down like this, 70% or so of the impact of making products, footwear, is coming from the materials, and the other 30% is from the processing and manufacturing of those materials into the parts. So another quick poll, after just saying that, how much do our materials that we use at Nike, materials that we then use to put into our products, how much of that contributes to Nike's overall carbon footprint? Any guesses? I can't see the chat, by the way, so I don't know if there's any.
Oh, yeah, a bunch of guesses for 70% and 50%. Yeah.
Yep, you are right.
Yeah.
7%. So 70% of Nike's total carbon footprint, scope 1, 2, and 3, comes from the materials that we use to make our products.
Yeah. And I would just add, we've talked a little bit about this, but this is why we're spending 2 class sessions digging into sustainable materials because this is typical for apparel and footwear companies, and particularly for the outdoor and athletic companies, including my former company as well, was pretty in line with this too. So yeah.
And it's maybe intuitive once you think about it, but I think a lot of people think what they can visually see. They think about packaging and they think about transportation, and those are actually smaller parts of the footprint. Yes, transportation can be impactful when you consider air freight, air transport. That kind of changes the dynamics a little bit, because air freight, I think, is 42 times more carbon intensive than ocean and truck. So rush shipments, coming in by air is a big contributor to our footprint, but we're working on ways to reduce that. So it's getting better. So
and
maybe
this also, Adam, and just for clarity, that also includes, and I sort of misspoke in my last comment as well, because this also includes manufacturing as well, right? Like the manufacturing, like what?
Yeah.
So
right. When I say materials, I basically mean like what we call tier 4, 3, and 2. So tier 4 is the raw material. Tier 3 is the sort of knitting and spinning and weaving. And tier 2 is the dyeing and finishing of those materials.
Yep.
It's all technically the material you need, but yeah.
Perfect. And these guys have seen that and are starting to use that terminology too, which is great. So
Cool.
Yep.
So just another sort of pie chart showing the breakdown of the materials really representing the biggest part of our footprint, and then you have other areas like logistics, which is transportation, and our office space and our distribution centers and our retail stores, that contributes to some of the carbon, but only about 4%. And then end of life, when these products end up in a landfill, most of our footwear and apparel products unfortunately do end up in a landfill. I think it's like 60 to 70% globally. 30% roughly gets combusted or incinerated. And so that's the carbon impact from those areas too. We can then even kind of further deep dive and say, okay, of those materials that we're consuming for our products, which materials represent the different parts of our materials footprint. And for Nike, probably similar to many other footwear apparel companies, polyester, which is a pretty versatile petrochemical derived material, has a pretty big impact. We use a lot of it, and it has an impact. And so that is the majority, the vast majority of our footprint in the materials space is from polyester. Followed closely by cotton, rubber, foams that we use like EVA, ethyl vinyl acetate, which is the white midsole that provides cushioning for footwear. That's also from the petrochemical industry, leather, as I mentioned earlier, and then a lot of other materials. So that's kind of like our footprint, including a deep dive into the materials. I like this chart. This is kind of like how our footprint kind of compares to global footprint and the industry footprint. So you can imagine this like one of those like solar system diagrams where you've got like the sun in the background, which is number 5. That's like global carbon emissions, right? And then you have the smaller, maybe like Jupiter thing here, which is the industry's contribution to that global footprint. So this is the total footwear and apparel industry, which I've heard, estimates like anywhere between 4 to 8% of total global carbon emissions is the footwear and apparel sector. So we're a pretty sizable contributor to the global carbon emissions issue. And then within that, you can see these smaller like moons and Earth planets are the different parts of our value chain. So you've got our, we call our materials footprint, which is number 3, which is the majority of our footprint. Number 2 is sort of our kind of closer in manufacturing, like assembly processes. And then number 1 is our owned and operated space. So this is, scope 1 and scope 2 emissions. So again, our office space, our distribution centers, it's a very small percentage of our total carbon footprint. So that's a bit of context. So now I'm going to move into a section on intro to LCA, which might be a little bit theoretical and kind of dry, but so let's see how it goes. And if it's too much, we can kind of skip over to the applied stuff. So I think all that context really is coming from the use of life cycle assessment behind the scenes, right? We want to be able to make database decisions about sustainability. And to enable that, we need to use life cycle assessment to drive those decisions. So when we're calculating carbon footprints of individual models or innovations, our whole goal is we want to compare the impact of a new innovation that we hopefully will build and bring into the market, and compare that to kind of current state or benchmark technologies. And that enables us to understand, okay, is this innovation that we're building going to reduce our footprint or not? And that is our ultimate goal. So a little bit about what LCA is, and it sounds like you guys already are pretty maybe well versed on this. LCA is a quantitative assessment of the environmental impacts across the full value chain, right? So we're looking at the, everything back from the raw materials, the manufacturing, distribution, use, and disposal. And all of these stages are consuming resources and contributing different impacts back to the environment. We talk a lot about carbon footprint, which is just one component of LCAs. LCAs look at a lot of other impact areas, right? Weird things like eutrophication or abiotic resource depletion or water scarcity or toxicity. These are all other impact areas that can be calculated or quantified through the use of life cycle assessment and then exposed to users, consumers, practitioners to then try to optimize and understand where are they coming from and how can we better manage them. So why would you do an LCA? Well, first you want to understand the product system. You want to understand hotspots. You would like to, be able to make meaningful comparisons. So environmental claims like, oh, this shirt has 30% less carbon emissions than this other shirt. You need to use LCA to do that. And some of the things we look at when we're building LCAs are all the inputs that you need to make things. Whether or not you're using recycled materials, what kind of additives or pigments or chemistries are you using. You want to be able to look at any kind of processes that you're doing to those materials, dyeing, knitting, any kind of embellishments or treatments. And all of those will have various levels of impact, and you want to understand what those impacts are, and then hopefully, make some recommendations on how to improve them. So there's some phases in doing a classic LCA. First you kind of define the goal and scope. What are you trying to assess here? what are your boundaries? I kind of mentioned, like, are we looking at cradle to gate? Are we looking at cradle to grave? Are we including transportation, not including transportation? These are all things you want to set out before you do your study. You then want to understand the inventory. So these are all the inputs you need to make the thing that you're studying. You then need to translate those inputs into impact, right? So for example, an input might be you need electricity. The machine needs electricity to do the knitting process. Okay, well then the impact of that electricity is maybe the carbon emissions associated with that electricity. And so there's an impact assessment layer that you need to apply to inventory to get to your midpoint or your carbon emissions. And then you have to interpret the data, right? How do you contextualize carbon emissions? I showed you earlier some footprints of different shoes. You know, those numbers are interesting, but sometimes meaningless if you're not bringing them into context. Like, what does 10 kilograms of carbon mean? How does that compare to other shoes? So that's all enveloped in this interpretation phase. When you start an LCA, you also have to define what's called the functional unit. So what are we measuring? So essentially, what is the function that your product is planning to deliver? And that can be defined by looking at these questions. You know, what are you trying to do? How much of it are you trying to deliver? How well does it deliver that function? How long does it deliver that function? And then where does that deliver that function? So for example, you might look at you know, a shirt or a fleece, and you want to understand the carbon impact of that fleece, that garment. Okay, so to determine the functional unit, you might need to say, okay, what is this fleece doing? Okay, it's providing warmth to an individual based on those material properties. Okay, well, how much material do you need to provide that warmth? So then you need to define, okay, how much material are we looking at? 3 square meters is typically what you need to make a garment. And then you need to understand, well, how well is that 3 square meters of material delivering that warmth to the person that you're building the product for? How long can you deliver that warmth? And where does it deliver that warmth? All these are questions that are kind of captured in this term called the functional unit. You then need to provide a reference flow. So how much of that functional unit do we need to deliver to provide that function? So an example of a reference flow is, you know, looking at materials on a per kilogram basis, right? Like, that's the denominator. You're assessing a kilogram of polyester to a kilogram of cotton. Or you might look at a pair of shoes, you know, one pair of shoes versus another pair of shoes. Or, as I just said, a square meter of material. Those are all examples of reference flows. You then need to understand, like, the system boundaries here. So I kind of mentioned this earlier, like, what are you looking at? What part of the value chain are you planning to include? And there's pros and cons of different parts of the boundaries, right? So for us, when we want to understand impacts of the products that we're making, it makes a lot of sense to look at things from a cradle to gate boundary, because we can affect the materials, we can affect the manufacturing. We can't really do too much on the use phase, how consumers use our clothes and our shoes. You know, there is impact, for example, for washing and drying, you know, apparel garments, but you know, what can we do? Is that relevant to a material developer or designer who's building the next, you know, apparel garment, for them to understand that impact if they can't really affect it? Other areas, you might want to look at the full cradle to grave implications. You know, when we do environmental claims, it's probably important to include that, because that is the full impact of the apparel or footwear product. And then sometimes you might want to zoom in and say, like, let's only look at manufacturing processes, because we want to understand hotspots within that one zone and understand how to optimize there. So boundaries are an important part of LCA. So when you're building LCA, I like to think of it as like puzzle pieces. You have to kind of understand the process flow of your boundaries. And you want to break down that process flow into individual unit processes. And these unit processes are like the puzzle pieces, you know, one step to the next. You need the raw material first, that's one process. Then you need to know, like, how do you convert that raw material into a yarn? That's the second process, spinning, let's call it. Then you need to take that yarn and do another unit process, knitting, to convert that yarn into a piece of fabric, textile. Then you need to take that fabric textile and dye it, color it. That's another unit process. So you're breaking down this flow of manufacturing something into these unit processes. And each one of these unit processes has inputs and outputs. And that's what you're evaluating as you build up an LCA. So an example, and this is going to look kind of crazy, but this is an example of the full value chain for polyurethane foam. And it's showing you all the individual unit processes that are needed to make a polyurethane foam material. And so this is just a process flow diagram, and it goes all the way back to the raw inputs, the crude oil and the natural gas that's used to then derive this polyurethane chemistry. And you can see all the steps that are needed. And in each one of these steps, you have inputs and outputs. And LCA is just combining those inputs and outputs and expressing those impacts at the full sort of product level, right? So you can kind of sum up all of these inputs, sum up all these outputs, and you can calculate the overall impact of this polyurethane foam. Okay. So yeah, so life cycle inventory, it's kind of what I've just been saying. You're looking at these flows in between each unit process, you're understanding what those flows are, and then you're trying to understand what the impact to the environment is. All right, so an example of this is kind of about interpreting the life cycle inventory, all those inputs, into some sort of a environmental impact output. So you can think of like greenhouse gas emissions. So this is talking about carbon footprint. Each one of those unit processes will have an emission of a greenhouse gas, right? And there are more than just one greenhouse gas. There's CO2, there's methane, there's N2O. All of these gases are emitted as elementary flows across these different unit processes. We then have to convert those elementary flows into a carbon footprint, right? What we call a global warming potential. And so this is getting into characterizing those elementary flows, those gases, into a global warming potential. And that's what we use something called impact assessment to do that. So you can convert the CO2, the methane, and the N2O into carbon dioxide equivalents, which is based on their relative global warming potential to derive a carbon footprint. So that's what we're doing here. We're calculating CO2e. It's what's called the midpoint, the kilograms of carbon equivalent, based on those elementary flows. LCA goes even further sometimes, and we don't really necessarily do this, but you can then go further and take those midpoints, like the carbon footprint, and try to calculate what are called endpoints. So what's the damage to the Earth by those carbon emissions? That's a little bit more complicated. It's a little bit outside of my wheelhouse, but it's the ability to express those environmental impacts as sort of like a impact to the planet. Like, what damage does that do to the planet? How does that harming the planet? And that's a little bit harder to explain, but you can do that with LCA. Okay. So I think, again, this is just kind of repeating. I think the point of this slide is that there are a lot of assumptions and a lot of nuances to doing LCAs. So not all LCAs are created equal. There have been many cases where, you and I could be doing an LCA of a, plastic water bottle, and you come up with slightly different scope and goal and use maybe slightly different data, and we could come up with impacts that are completely different for that same product. So understanding assumptions and kind of being consistent with the data that you use and the methods that you employ is a big kind of deal in the LCA industry. And it's something that, for example, the Higg Index is striving to make better, right? The fact that the industry has now aligned somehow on using similar data source, the MSI, to understand impact of materials that we all use across the industry, is helping to create that consistency across doing environmental assessments. Because if we all use different data, then we're not necessarily speaking the same language. All right.
Yeah, this is a really important point, which is that put another way, even though there is a standard protocol for doing an LCA at a high level, there are so many different ways you can interpret the scope of the different boundaries and what's included in these different stages that you see here in this diagram, how you apply assumptions to different pieces of data. So it becomes really important for a tool like the MSI to come in and try to provide some of that comparability among life cycle assessment data, because just because a life cycle assessment was done on a certain material, if you just at face value try to compare that to another life cycle assessment that's just out in the world, it's most likely not actually comparable, because there are just so many different variables that can come up during the process. So
absolutely,
just to restate the point you were making there, Adam.
Yeah, no, thanks for that. That's great. Exactly, and exactly right. All right, so last couple on this sort of theory, just to kind of explain how all that theory, like how we interpret it and what our kind of plan is. We've obviously thought about this and established for ourselves like what our goal is and our scope, our functional unit, looking at pairs of shoes, looking at garments, looking at mostly cradle to gate at this point, but probably evolving in the future to look more downstream from that. And then some other sort of nuances about the data that we use, the impact assessment methodology that we use to convert those inventories into impact. And all this is in line with the latest, LCA kind of thinking. And so, just to kind of give you that background. So next I want to kind of get into applied LCA. One of the things that's, really challenging for a company like Nike is that we use so many different materials and we have so many different, actors in our value chain, manufacturing partners, et cetera, that we need to give, one of the roles of our team is to give guidance to our innovators and our material developers and our material designers to understand what do they need to be able to calculate carbon footprint. And so we've built a bunch of tools, resources, processes to do that. So I want to kind of talk through those quickly. We've built up what's called the Carbon Playbook, which is an end-to-end guide that explains to our material developers, designers, developers on what they need to do, what data they need to collect, and what is the method to calculate carbon footprint. It involves processes for collecting data, reporting on the data, our interpretation of the Higg index, which I'll explain in a second, trying to kind of make this process more consistent so that we can do things like compare innovations to benchmark. Ultimately, I kind of said this earlier, we're looking at calculating the impact of new innovations, new things we're building compared to a baseline technology and trying to understand the carbon differential. Obviously, if we are building new innovations that increase carbon, that's not good. We want to find innovations that reduce carbon. And again, we do this by collecting data, doing LCAs, developing process flow diagrams for innovations, and understanding that same kind of apples to apples comparison with our baseline technologies. We even gone as far as creating an external guide that we give to our material vendors, because no surprise, Nike doesn't really manufacture chemicals or materials. We rely on external partners to do that for us. Of course, we have specifications, what we want, but ultimately it's bigger chemical companies that are making the materials for us. And so we've actually developed a guide that we give to our vendors, and we have these conversations with them like, hey, we want to understand the life cycle impacts of your materials. You're the ones making it. Can you use this guide to expose that information for us so that we can use it to calculate the footprint of our products that we're making? It's one element of the overall assessment. We're using this sort of methodology, this process to do carbon analytics. A lot of it is still manual, spreadsheets, weighing parts of products, literally like on a scale. and, you know, mapping those different parts to impact data for those same materials, you know, using Higg, for example, and then, you know, reporting on that and explaining to our innovators and to our developers like where the impact's coming from. There are some tools I'm going to get into in a second that are going to hopefully make this more automated. It's not complete yet, but it's something exciting on the horizon. And so, you know, how that report might look, you know, this is an example of, you know, a benchmark football boot that we assess the carbon footprint of, you know, 8.4 kilograms of carbon, and then some new innovation product that we're working on, and what the differential is, and how it's broken down by the different parts of the shoe. And so this is hugely important for developers and innovators to see, because now we're using carbon as another metric, and now there's, oh, okay, here's where I need to work on, you know, reducing impact in this area, and what are my opportunities, and etc.
I'll just add on this. This is incredible. This is really leading work right here for the industry. Like, there are not a lot of other companies, if any, who have this level of product level decision making, I would say, built in around carbon impacts or other environmental impacts built into their product development process in this way, or decision making process as part of that. So this is, just so you're aware, this is not like something that's common in the industry. This is really really leading work, actually. So, and you know, I know Nike's been working on this for over a decade now, essentially, leading up to, probably longer, really, if you think about it, all of the precursor work on your initial you know, materials data collection, you know, the original material sustainability index that now, you know, has formed the basis of what's now evolved into the broader Higg index tool. So
yeah, exactly. And that's a perfect segue to, I want to just talk about a couple resources. One is the Higg index, which we're going to jump into in a second, and the other is our kind of proof of concept, you know, version of automated product scoring, which uses the Higg index as one of the inputs. I'm going to jump into that in a second. All right, so Higg index. So I think you guys have seen this. Beth, have you actually like taken the team through the MSI?
Well, no, because it's challenging. I've been trying to get access, and it's a challenge, unfortunately, for academics. So yeah, if you are able to, and they would have seen it on the video, but on the How to Higg video, but if you're able to walk them through it, I think that'd be great. Yep.
All right, let's just spend a few minutes doing that, because I think it'll set up the next thing.
Yeah, agreed. That's great.
So this is the Higg index, and again, how you can think of this is it's an industry aligned LCA database that looks at the key materials that the footwear and apparel industry uses, and it breaks down those materials into the different value chain areas. So let's just take an example. So for example, polyester, we talked about polyester before. What it's doing here is it's showing you the impact across these different impact areas. So we've been talking a lot about global warming or carbon footprint, and that's just one impact area associated with the manufacturing of polyester fabric. But there are other impact areas too that, you know, are also quantitative. You know, as I mentioned, eutrophication, water scarcity, resource depletion, which is basically like how much fossil fuels are we using, and then some chemistry impact. What's cool about this tool is that within each of these materials, you can get a breakdown of the different parts of the value chain. So these are those unit processes I was talking about, the puzzle pieces. So to make 1 kilogram of polyester fabric, you're essentially consuming 10 kilograms of carbon. Of that 10 kilograms of carbon, how is that broken down? Okay, 3.5 kilograms of carbon is coming from the raw material itself. So the polyester pellets that are coming from the petrochemical industry. Those polyester pellets then need to be extruded and spun into a yarn. That's the yarn formation method. So you're making a piece of thread out of it, out of those pellets. And that's contributing another 2.2 kilograms of carbon. Then that yarn needs to be knit or woven into a piece of textile, right? Like a knit textile. So that's another 0.3. Then it needs to be prepared to be dyed. So it's called scouring. And then it needs to be actually dyed. So batch dyed. And so all these pieces together come and give you that 10 kilograms of carbon. The MSI has a lot of processes underneath, so you can make choices and say like, okay, I can click into this and say like, what if I wanted to use mechanically recycled polyester raw material instead of a virgin polyester? I can make that choice, and by making that choice, you can see that I've changed my impact from this virgin polyester from roughly 3 kilograms of carbon down to 0.7, right? So if I go back here, now my 10 kilograms of carbon for making this material is now only 7.5, right? So just by us making that choice to switch from virgin raw material polyester to recycled polyester, I've reduced the impact of my polyester fabric by roughly 30%, which is pretty cool. And this kind of information lets us quantify the impact reductions of these initiatives, and also even shows us what makes a difference, what doesn't make a difference, where should we focus. So I just wanted to walk through that really quickly. I mean, there's lots of other materials in here. I think there's roughly like 100 materials that are sort of pre-baked with sort of these options already selected. But within this sort of universe of LCA data, I think there's roughly 500 processes that you can kind of piece together based on different choices that you make. So it really is this library of environmental impact data that you can use to calculate the impact of your materials. And if I switch back to my presentation mode, that's kind of where I want to go next, is how Nike has applied this data. So we've taken this Higg index information, as I just explained, and looked at all of the materials that we use in our materials library, which is roughly 200,000 unique materials. And we've done this mapping. We've mapped each of those processes to the attributes associated with that material. So, you know, what material am I? Am I polyester? Am I cotton? You know, how am I knit? Am I woven? Am I dyed this way or dyed that way? We've done that in a sort of an automated way, so that someone is not manually like clicking on processes. It's sort of reading and not using an algorithm to match up the Higg processes to our materials information. And this lets us now calculate and expose impact carbon footprint data for any of the materials we have. So you can look up, you know, all these materials have this unique ID, you know, 1, 2, 3, 4, 5, and it'll tell you everything about that material, where it's from, what material type is it, how much does it cost, etc. And so now we have that done in an automated way, and then we can do analytics with it, as I'm showing here. But we can also build that into, I don't know why it's not moving to the next slide, sorry. Build it into like our materials library, right? So this is what a material designer developer is looking at every day. They're picking materials for their product, and we can expose to them the carbon footprint associated with those materials, so that the choices that they're making is real time, right? We're not building the product and then later saying, oh, by the way, did you know this footprint of this product is 10? Like, why did you do that? It's like, well, you can see the materials that you're planning to use and make a choice just like you would with cost on using a lower carbon footprint material. And if this is too much information, which sometimes it is, you can start to, you know, qualify the ranges of different material types. Like, for example, for synthetic leathers, you know, you have a whole gambit of synthetic leathers you can use, and they all have different carbon scores. Well, we can translate those carbon scores into, you know, good, better, best, which makes things a little bit easier for a designer to kind of understand. So this is like a real-time application of life cycle assessment data using industry-leading databases that's automated and delivered to at a point of decision making, which is, I think, where we need to go. And you know, this is on the material level. what I want to show next is taking this another level up, where you now are calculating impact at the product level. Because again, what I'm just showing you here is impact per kg, right? But if you want to understand impact of a product, you need to know what materials am I using on that product, how much of those materials am I using, and what does that give me in terms of carbon footprint. So I have a little video of a quick demonstration of our Impact ID tool, which is the name of our automated product scoring tool, which again looks at materials and a little bit of manufacturing. It's 3 minutes long, so I might kind of jump around a little bit and I might pause.
So this is the line item breakdown of this product directly from the CBD. In this case, it's usually the CBD or the BOM of the product.
CBD or BOM is cost breakdown. BOM is bill of materials. So what this is showing is we've brought in a bill of materials, which is basically the ingredients of making this product, all the different things that are needed on it, the different parts, the different materials, and that's the first step. We need the ingredients of the product.
You know what we have access to. It's kind of structured the same way. You can see a summary up at the top. What's the mass of this product? What's its global warming impact in kgs of carbon emissions? What's its recycled content? And then the list of all the materials that appear on that product, how they're being used, and how much they weigh, or what their mass is, because that obviously determines the different summarization here. So we're actually going to walk through and we're going to replace a material. So we're going to take the previous version of the lace that was on this product, and we're going to pull in a different material, which is, I think it's 100% recycled version of this lace.
Okay, so real quick. So he's jumping into already kind of scenario modeling, but I wanted to just show you that, this is pulling in automatically the bill of materials of a product that you're looking up. It's matching up those Higgs scores that I just explained for each material. It knows how much of that material you're using, and it's showing you the carbon footprint of all those materials, and it's adding it all up and then showing you the total carbon footprint of that product. It also has information about the mass or the weight of the product, and it also looks at recycled content. And now what he's about to do is show you that this tool can also do scenario modeling, where he's about to replace one shoelace with a different shoelace to show you the relative impact of that.
And see, what does this do to my total impact here? So we can search for any material, lots of different attributes to search by. Of course, if you have the material ID, boom, you're going to go straight to it. Otherwise, if you're kind of looking for a selection of materials to find one to replace with, you have that option as well. And then we're going to scroll down here and find that lace to look for. Specifically, there is a filter option too. So if there's a lot of items like there is on this product, and a lot of footwear has quite a few items, you can filter to your specific item. Let's say looking for the word lace, you'll find the lace and you can swap it out there. So we go ahead and swap it out, and we give it its mass. We tell it how much it's going to weigh and how much it's going to contribute to the overall product here. And you can see up at the top the summary change, and we have these little highlights at the bottom that tell you how it changed. So we've swapped out to this lace that actually give us a little less mass and a little less carbon emissions there. And it's always by default going to compare to the original product. So in this case, the original CBD, but we can go ahead and save this as an edited version. Maybe this is a work in progress. Maybe this is the next season's product that you're planning, however you want to do that. So we're going to go and save that as a new one. And it's still going to compare it now to its current version. But what we can do is say, hey, actually, we want to compare this product to a similar product and see kind of how they balance out between the two. So we're actually going to look for now the tangent, and we're going to pull that in as the comparable product or as the baseline and see how this new version of the Revolution compares to that tangent product. So we'll pull that in here.
It's almost done.
Selecting the right one we want to compare it to. And now you can see the baseline is going to change. And now we're comparing it to the Nike Tangent. And now we can see the baseline values underneath show us, hey, it looks like this one maybe weighs a little bit more. It's got a slightly higher carbon impact and maybe has a little less recycled content there. And there we go. That's it. So that's really Impact ID in a nutshell, obviously.
All right. So that was just a brief demonstration of maybe the future of where we want to go with product carbon scoring. And, I think at some point, we're going to get to a place where we're going to be communicating this at the point of sale to consumers. And, we are all going to be better educated to know what these carbon footprint numbers mean. And it might be looking like, nutrition facts that you see on food products. So hopefully that'll help us make better decisions to reduce impact. I think we're a few years out from this, but I think that's the future. So anyway, that's it. That's what I got.